Hey folks, so today we'll be starting multivariate linear regression. So let's see what multivariate linear regression is. Okay, so in multivariate linear regression, what we have that we have features more than one. Okay, it is so simple that we have feature more than one. So we have like multiple features. Now we have to we have to work on the multiple feature data, the data which has multiple features. So let's suppose the example we have in which we say so you want to build a house project in which you have size of the house, number of bedrooms, number of fans, etc. So you have the feature number one, feature number two, feature number three. Okay, yeah. So the information we have is x1 x2 in the form of x1 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 x2 x3, which are the like features of the house, that what is the size or number of bedroom or number of fans, etc, etc. So what do we do in the multivariate regression? So we have seen earlier that what do we do in the univariate linear regression, that we, we used to build a function. Okay, this hypothesis in which we used to do that we have theta 1 which was theta 0. Okay, we have another one theta 1 into x1 where x is the feature, x is the feature and theta are the like parameters, or we can say the weights to we predict uh, we predict the labels. Okay, how the label is. So we used to have these things there. Now here it is the same, it is just same. So what do we have that then if we have n numbers of features, then we are going to have n numbers of parameters. Okay, what the case here is that if we have n number of features, n number of features, then n number of parameters. Okay, n number of parameters, and it's like, okay, so the note I have got from the Anton, like I'll be sharing the link. So this is what it is. So yeah, so what we have that beta 0, beta 1, it is just same. Like, okay, if you can take theta, theta is not just a variable, so you can't like mess up with theta or beta, because it is just a variable, or you can say the parameter. It's just same, it's all same, you have to put value in it, it's same. Okay, so we can say that we have n numbers of features, so we have n number of uh, parameters. It is so simple as that. So what we can do also is this, like if we have extend in a smaller thing, then what we can do like this, we can write like this beta I by, yes, okay, from 0 to all to the around to the n. Okay, now the case here is that we have to predict one value. Okay, what do we have to predict? That we have to predict one value from multiple features using the parameters we have. Okay, so what will we do, that we will take all the features and we'll put it into the, and we'll give it to the function, the hypothesis function, and it will give us the y, the predicted value, the value which we want. It is as simple as that. Okay, so the data we're going to have, okay, so the x we know all, is all, it is the label, or we can say the feature. Okay, so it is like, yeah, so the label of feature. Okay, we know this is the label, right? This is the label or the feature, not label, sorry. Label is nothing, label not label, it's feature. Okay, I messed up, I messed up something, but yeah, it's feature. Okay, it is the feature, it is x. Now it is in the form of matrix. Okay, is it is in the form of a matrix, which is showing here is x11. Okay, what does x11 shows? That row 1, row 1 and column 1. Okay, it is just showing the position of this feature, that what position is in it. Okay, now so we have this, so we have this first row and p number of column. Okay, p number of column we have, like p number of column. If we don't know, then we can say it, we have a p number of column and it is in the first row. Now if we go to the row by row and row, so we have n number of row. Okay, we have n number of row. If we can see horizontally, then we have n number of row and p number of column. Okay, so this matrix, we, so the size of the matrix is gonna be n into p. What it gonna be? N into p, right? Yeah, is it? It is gonna be n into p, which is the size of the matrix. Now what we have, that we have these also. What is this? This is the label. Okay, the value which has been given, the label, the output which has been given earlier. So we have to predict something similar to this. Okay, similar to this, which is in the form of a vector. Okay, which we can say is in the form of vector. We have like n number of, yes, n number of rows and only one common, which is the size of it. It is n into 1. Okay, so we have to predict this. Now we have to uh, give each and every column, sorry, each and every row the parameters, so we can get the one label. Okay, one predicted label. How will we do it? How will we do it? It is what it is. Okay, so how do we do it like so? We have this matrix like this. We have n numbers of p number of column like this p number of columns. Now what will you do? That we have a matrix, sorry, we have a matrix, not the thing which we have is the vector. Okay, do you know the vector? The vector which has like only it has only one row or one column. Okay, it has only one row, that it has only one row and one column. So what we're gonna do, that we will have a column, sorry, a vector, and we will multiply to the matrix x. Okay, we will multiply to the matrix x, which is full of features. Okay, which is full of features, and we will get our corresponding y. Okay, we will get our corresponding y. It is what it is. Okay, now how will we do it? So as I've told that we have told about that how the multiplication of matrix works. So what we do actually here is that I'll be like where yeah. So what before that what I have to tell you that the number of row we will extend it one more. Okay, the number of row we're gonna one more number of row, sorry, column. Okay, sorry, column. We're gonna have one more number of column, cause we have something known as beta 0. Okay, we have something known as beta 0, in which the value of x is 1. Okay, we can say it is the 1 because it is not affecting the beta. Okay, it is not going to affect the whole predicted value, because if the value of x is 1, then what the matter with it. Okay, so we are gonna one more column, we will add one more column which is full of only one for beta 0. Okay, or theta 0, right? So when we have a column full with one, then what we can do is that where's the beta? Okay, we can say it is the beta. So what happens here, let me do it here. Yeah, so what happens here, that if we have, why is it like, I think the, yeah, yep. So let's suppose this till p, and yeah, this is n. Okay, and this is 1, and to this to the number of x n p. Got it? Yeah, this is, we have the matrix this, and the size of this will be, let me do it, this size will be, this is number of row is n number of row into p plus 1, because we have a one more column which is full of 1. Okay, we have one more column, we'll let it load first. We have one more column which is full of 1, so we can add to this in the matrix also. So the matrix will be this, okay. So let me like in the next yes, okay, let me show you here. Yeah, so we have this till the 1p, and we have like, so we have this n number of row, first column, all to the way around to the n into p. Now the size of this matrix is n into p. Okay, the size of this matrix is 1 into p. Now what will you do with it, is that we will add one more column. It is the new added column, new added column, new added column. So the size of this matrix is going to be n into p plus 1, because we have one more column, so we have to add one. Okay, got it? Now we have to multiply it this matrix with the vector which is beta. Okay, beta or theta, whatever you're gonna tell. Okay, vector which contains all the parameters, okay, which contain all the parameters, beta 2, beta 3, all to the beta n, sorry, p. Why? We're gonna see beta p. So what will happen is that, as we know the matrix multiplication, what we do, that if we have to multiply the matrix of the two matrices, it is a form of matrix also, but it has only one column, okay, it is a form of matrix also. So what we're gonna do is we'll multiply this matrix with this. So what we need to do, that the number of row which is p plus 1, it is the number of row and number of column, and this is p plus 1, sorry, 1 into p, 1 into p, sorry, it is not 1 into p, it is p into 1, okay, I got confused also sometimes, but it is p into 1. So as we know that if we have to multiply two matrices, then the number of column must be equal to the number of row of the another matrix. So this case satisfies here, this thing satisfies here, so we can multiply with this. How can we multiply this with that? How we can do this, like, we will multiply this one with the beta 0, and then we'll do with this, and we'll do with this, and like all to the p, okay, all to the p will this, like this. And what will you do, that beta 0 plus beta 1 into x11, okay, this will like continue to beta 2 x, beta x to 1 2, okay, and we'll be moving to beta 3. So it will go till beta p, okay, for the, like, because we have p number of column, so we have to multiply it for p times, okay, for p times. Are you getting it? Because we have p column, okay, the number of column we have is p, it's row, but we have p column, the number of column it is p, okay. So the p, and we'll multiply it with this and this. Now we will get the first, our predicted value, which is y1, okay, which is y1, y hat 1. As like that, we're gonna by 2, by same, in which we'll the number, the row changes, in which we have 2 1 plus this like this, and like, oh, let me do it where it was, yeah, here. So it will be like this, and we will end up having these value, okay, we'll end up having these value, which is our predicted value. So this is and this is, okay, this is and this is. So that's how our matrix will, our resultant matrix will be like this, okay, which is a vector. Our resultant matrix will be like this. So which is y hat 1, y hat 2, y hat I till y hat n, because we have n number of row, and the resultant matrix have n number of row of the first matrix, okay, number of row first matrix, okay, into number of column second matrix, okay, right. I have told you in the earlier part. So this is the resultant matrix we're gonna have. So the case here is, what we do, that we have two matrix, in which the first matrix, okay, so we have two matrix. Let me, yeah, go to this. So the summary, if I say you, what we are gonna see here is that the sum, if I summarize this thing, whole thing, then we have two matrices, okay, we have two matrices. The first matrix, the first matrix is a full of features, okay, the feature we're gonna have all the feature. And the second matrix we have is of parameters, okay, is of parameters, all those beta or theta, okay, whatever, like you can take also theta also, but it's just a variable kind of thing. So what we do here is that we have a beta 0, beta 1, all to around to the number of column, okay, the number of column, let's suppose the number of column is p, and the size of the first matrix is n into p. So we have this matrix and we have the second matrix. So we have the values here, we have the values and the number of column, number of rows, as we can see. Okay, so this is, we have the whole matrix. Now the number of column, and this is this. So this is matrix is NP. Okay, this is, and what we do, that we add another column which is full of 1 to the first matrix, and we dot product of it. Okay, so in the numpy, what we do, that there is something called as a dot product. Okay, we don't like multiply as we do in math. What we do, that we multiply it with dot product of it. Okay, what we do is we do dot product of it, and we get a resultant matrix vector, we can say, which is y hat. Okay, y hat vector, which is full of uh, the multiplication of product of all this thing, sum of, okay, the resulting matrix. So it will be y hat 1, 1 y hat 2, all to the round to the, or y hat n. Okay, y hat n. So this is what we're gonna get. Okay, now in the next thing, in the next part, what we'll see, that we will see how do we like check the cost function. Okay, how do we check the cost function, which cares about the error. Okay, that how far the like predicted values from the like real value, the ground truth. Okay, that how far our predicted values from the ground truth. So there are like a lot of function, MSC, MA, if I haven't told you about that, RMSC. Okay, it is mean squared error, it is mean squared error. The second one is mean absolute error, and the third one is root mean squared error. Hmm. The third one is root mean square error. This is so yeah, we're gonna wrap up now. This is, we have summarized you. So what in the multivariate thing, you can like watch it before. So yeah, I'll be seeing you in the next one.